In this video, we're going to discuss the concept of limiting reactant or limiting reagent. If you're trying to do a reaction, say you're trying to cook cookies, and you need 2 eggs, 2 sticks of butter, 2 cups of flour. Well, if you start mixing it together and you have only 1 cup of flour, you can't make a full batch. You don't have enough. You could make a half batch, 1 egg, 1 stick of butter, 1 cup of flour. But the idea is you couldn't make any more than the flour let you make. If you tried to throw in the extra eggs and butter, it probably wouldn't come out as very close to a cookie. So the idea of limiting reagent is that if you don't have enough of one chemical, that's where you stop. The moment you run out of one of your things that you're using to do the reaction, you can't continue to do the reaction. And so if you had CH4 and O2, burning becomes CO2 and water. Well, let's say you start with 10 methane and 0 dioxygens. Can this burn? No, you don't have any oxygen. It can't burn. Say you have 10 methanes and 2 oxygens. Well, sure. 1 of my methanes can go away. 2 of my oxygens can go away. I'll end up producing 1 carbon dioxide and 2 waters. And then I go to burn my second methane and nope, there's no oxygen left. The idea, again, is if you run out of a chemical, you can't make any more product. Limiting reagents are extremely common. If you ever mix things, there's always going to be one of them that runs out first. Anytime you have 2 real masses of starting material, we will have to consider that this is a limiting reagent problem. So if you're ever given a weight, 2 real weights, you're not given 1 and then told to figure out how much product it'll make. You're giving 2. You say, hey, I have this much methane and this much dioxygen. Well, that is 2 weights of starting materials. That means one of them will not be enough. Let's try 20 grams of CH4 and 33 grams of dioxygen. Well, we're given 2 real starting weights, and our question is that we want to find the mass of CO2 formed. So I'm going to throw these 2 gases in a container, light it on fire, and make some carbon dioxide. One of them will run out first. So the maximum carbon dioxide I can make will be dependent on whichever runs out first. So how do we determine which runs out first? Well, really we don't. We just calculate both. The simplest way to approach a limiting reagent problem is to convert both starting materials to product. So I would take my 20.0 grams of CH4. I got to get out of grams of CH4 and into moles because I can't compare molecules unless they're in moles. Well, I need a ratio of grams and moles of methane. I can use a molecular mass for that. Carbon's 12, each hydrogen's 1. 16.05 grams in 1 mole for methane, if you add it up from the periodic table. I can then get out of mole CH4 and into mole CO2. My balanced reaction up above lists that as 1 and 1. And so 1 to 1. And then, well, actually I can just stop there. What this does is this tells me how much product my methane can produce. What is the maximum amount of carbon dioxide that my methane would be able to produce? What we find is that it is 1.246 mole of CO2. If I try this with the dioxygen, 33.00 grams of O2 I need to get out of grams of O2 and into moles of O2. Well, that is 32.001. And then I need to get out of mole O2 and into mole of CO2. Now that balance reaction tells us it's 2 moles of dioxygen for every 1 mole of CO2. What we'll find there is that this is 0.5156 mole CO2. What we have done is we've taken a weight of each starting material and said if all of that starting material converted, this would be the max CO2 for each starting material. Well, you can only make as much product as the thing that runs out first, which means whichever you make the least product with is the thing that ran out first. And what we find is that's dioxygen. I can only make a little over half a mole of carbon dioxide from my dioxygen. I could make more than a mole from my methane. So my oxygen will run out at the point it has made 0.515 moles of CO2. The remaining methane has nothing to react with and never got used up. What this led us to determine is that O2 was our limiting reagent. It is the chemical who produces the least product when we take it through the calculation. It is our limiting reagent, and this is our max possible product. We cannot make any more carbon dioxide than this. In fact, now that we know that, we could use that to solve the other product. We could say, find max H2O produced. Well, the limiting reagent doesn't change depending on which thing you're looking at in the balanced reaction. Oxygen is still the limiting reagent. You could do this calculation again for both methane and dioxygen and convert it to water. You'll find in the end that oxygen is still the limiting reagent. And so we could just convert to that directly if we would like. 33.00 grams of O2 is 32.00 grams of O2 in 1 mole. I need to get out of mole O2 and into mole of water, and they are 2 to 2. And so this would give us 1.03 mole of H2O max. Just to highlight the point, if I tried to convert my methane to water, well, same as before, it's 16.05 grams of methane in 1 mole. I need to get out of moles of CH4 and into mole of water. For every 1 mole of CH4, there are 2 moles of water in our balanced reaction. This comes out to 2.492 moles of water from our methane. So even though the moles of water we are making are different, they still find that dioxygen makes the least. Doesn't matter which product you try to calculate from your starting materials, the limiting reagent will still be the limiting reagent no matter what. And so dioxygen is our limiting reagent. And so what we found in both cases is the amount of product we make. When we actually burn our 20 grams and 33 together, I will obtain a little over a mole of water and a little over half a mole of carbon dioxide. If you wanted to find the masses, you could take those on using their molecular masses. 1 mole, 44.01 for carbon dioxide, and 1 mole of water, 18.016 grams for water. And so you could calculate out those masses by taking it one step further. But this is the idea of a limiting reagent. Whichever compound you will run out of first, that is the one that determines the maximum product you can form. And the way to determine which one is limiting is to take both starting materials, turn them into moles of one of the compounds, and make sure it's the same. You don't want to accidentally have one of these calculate water and the other calculate CO2 and compare them. They have to go to the same product. And so that's why we did these as a pair. Dioxygen here went to water. Methane here went to water. When we did it up above, dioxygen went to CO2, but we compared it to methane going to CO2.